Let's look at an example of simplifying a trig expression using our power reducing formulas. In this case, we want to simplify the expression cosine to the fourth of x. We want to reduce that down so it only contains linear terms of cosine. So we don't want to have cosine to the fourth, cosine cubed, cosine squared. We just want to have cosine terms. And it's okay if we have multiple cosine terms. It's okay if the inside, so what we're taking the cosine of, is not just x. We just want to get rid of all the exponents, all the powers. Okay, so just real quick to review what our power reducing formula is for cosine. We know if it is cosine squared of x, we can rewrite that as 1 plus the cosine of 2x all over 2. So I can rewrite a cosine squared as 1 plus cosine of 2x over 2. So the power on this new cosine is just a 1, so it's a linear cosine. All right, so how do we apply that to cosine of 4x? Right, we don't have a reducing power for cosine to the fourth power, just for cosine to the power of 2. So I need to figure out how can I rewrite cosine to the fourth power as a cosine squared, which we can do that. It's not too hard. So cosine to the fourth, remember when we multiply values, we add the exponents. So cosine to the fourth, I could think of as cosine squared times another cosine squared. Right? Cosine squared times cosine squared is cosine to the fourth. And both of these are cosine squared, which means to both of these I can apply our power reducing formula. So instead of having cosine squared x times cosine squared x, I'm now going to have the quantity of 1 plus the cosine of 2x over 2, that's the first cosine squared, times the same fraction, 1 plus the cosine of 2x over 2. Okay. Now, you might think that, hey, we're done writing cosines. We have both of them with powers of 1, and so we're done. But we want to simplify it because technically when I multiply these two fractions, I'm going to end up with another cosine squared. Okay, so we're not actually quite done. We want to keep going here. So let's go ahead and rewrite this. So in the numerator, I have the quantity 1 plus the cosine of 2x times the same quantity, 1 plus the cosine of 2x. And I'm going to need to FOIL that. And it's all divided by a 2 times a 2, which is a 4. So to FOIL, we're going to take our first numbers there. So 1 times 1, which is a 1. The outside numbers is going to be a 1 times the cosine of 2x. So that's the cosine of 2x. The inside is also going to be another cosine of 2x. And then the last two terms are going to give us a cosine squared of 2x. Again, all of that sum is still over 4. Now, the first three terms, the 1, the cosine of 2x, and the second cosine, well, actually, we can actually combine those cosine of 2x's, right? 1 plus a 2 cosine of 2x plus a cosine squared of 2x all over 4. So the first two terms here, the 1 and the 2 cosine of 2x, those are linear terms of cosine or just a constant. So those terms are done. But it's this other cosine squared of 2x that we still need to simplify. Okay, so because all of this is written over 4, let me go ahead and break that fraction apart so that we can isolate the cosine squared term. So I'm going to take each term in the numerator and write it with a 4 in the denominator. So we're going to have a 1 over 4 plus a 2 cosine of 2x over 4 plus a cosine squared of 2x over 4. Okay, and the 2/4 is going to reduce. So we have a 1/4 plus a 1/2 cosine of 2x plus, I'm going to write dividing by 4 the same way. I'm going to write that as a fraction, 1/4 times the cosine squared of 2x. So again, the first two terms, the 1/4 plus the 1/2 cosine of 2x, those two are already done. It's a constant and then a linear term of cosine. I just need to take this 1/4 cosine squared of 2x and reduce its power. And I can do that using the same formula. So we're going to have 1/4 plus 1/2 cosine of 2x plus 1/4 times a 1 plus cosine of 4x all over 2. Now, where did that cosine of 4x come from? Okay, so going back up to our identity, we know that we have the cosine squared of x is equal to 1 plus the cosine of 2x all over 2. Well, if I replace this x with a 2x, then I'm going to take the 2x and multiply it by another 2 when it goes into our identity. So I'm going to have really a cosine of 2 times 2x, which is where I get that 4x from. Okay. So all that's left again is to simplify. We're going to have 1/4 plus 1/2 cosine of 2x plus, if I take the 1/4 and multiply it by our fractions, we're going to have 1 plus a cosine of 4x over 8. And just like I did before, I can break that fraction apart. So we're going to have 1/4 plus 1/2 cosine of 2x plus a 1 over 8, and then plus a cosine of 4x over 8. And I have like terms here. I can add the 1/4 and the 1/8. So 1/4 plus 1/8 I could rewrite as 2/8 plus an 8, and that's going to be 3/8. So I'm going to end up with 3/8 plus 1/2 cosine 2x plus 1/8 cosine of 4x. And I know again that that is equal to the cosine of to the 4th power of just x. So I've been able to take cosine to the 4th power of x and rewrite it either in terms of just a constant or a sum of cosine linear terms.